Okay, good afternoon to all. Welcome back. Today I am going to discuss about the chapter number 5 of deadlock of operating system. So before going to discuss this chapter, let's talk about the articles, concept of deadlock, system model, deadlock detection, resource allocation graph, methods of deadlock handling, recovery and prevention, explain Ranker's algorithm and safety algorithm. So first is your deadlock. What do you mean the deadlock? First thing, deadlock it is a part of the process management, and also it is a part of the synchronization of between the processes. So before going to discuss about the details or the any algorithms part of the deadlock, first to say what is the deadlock. Now generally, when the operating system handles the multi-programming concept or multi-programming environment, several processes may complete for a finite number of resources. So here what do you mean the resources? The resources means the resource which is used for the processes. Right now. So there are problem is that the number of processes is there, but as the number of process there is that amount of the resources is not available. So processes try to access the resources of different instance of different resources at a time. So suppose a process requests resources. If the resource is available at that time, a process enters to wait state, right? Waiting process may never change its state because the resource requested are held by other waiting process, and this situation is known as the deadlock. That means one process use one resource, but at the same time another process use the same resource. So that is known as the deadlock concept. So for example, P1 and P2, there are two processes hold one disk drive and each needs another one. And general example, suppose there are two train approaches each other at crossing. Both will come to full stop and neither shall start until other has gone. Traffic only one direction. So these are the many examples, general life examples in case of the deadlock. But you discuss about the process system when two processes try to access one instance of a resource, then the deadlock will occur. Next, come to the system model. A system consists of a finite number of resources to be distributed among a number of competing processes. The resources are partitioned into several types, each of which consists of a number of identical instances. And a process may utilize a resource in the following sequence. First is your request, second is use, third one is your release. Request in this state, one can request a resource. Use in this state, the process operates on the resource. Release in this state, the process release the resources. Next is your what is deadlock detection? Deadlock characteristics and in a deadlock process never finish executing and system resources are tied up. A deadlock situation can arise if the following four conditions hold simultaneously in a system. First one is your mutual exclusion, hold and wait, no preemption, circular wait. So first is your mutual exclusion. What is the mutual exclusion? At a time only one process can use the resource. If another process requests that resource, requesting process must wait until the resource has been released. So this is the mutual exclusion. Next is hold and wait. A process must be holding at least one resource and waiting to additional resource that is currently held by other process. The process must be holding at least one resource and waiting to additional resource that is currently held by other process. Next is your no preemption. Resource allocated to a process cannot be forcefully taken out from it unless it releases that resource after completing the task. So that is the no preemption. Resource allocated to a process cannot be forcefully taken out from it unless it releases that resource after completing the task. Next is your circular wait. Suppose a set P0, P1 to Pn of waiting state. Process must exist such that P0 is waiting for a resource that is held by P1 and P1 is waiting for the resource that is held by P2 and up to Pn minus 1 is waiting for the resource. So that is held by Pn and Pn is waiting for the resource that is held by P4. So that is the circular waiting state that is known as the. So these are the deadlock situation can arise if the following four conditions hold simultaneously in the system. Either mutual exclusion, either hold and wait, no preemption or circular wait. Next is your resource allocation graph, an important concept, resource allocation graph. Deadlock can be described more clearly by directed graph, which is called system resource allocation graph. The graph consists of a set of vertices V and the set of H, E. Right? So the set of vertices V is partitioned into two different types of nodes, such as P equal to P1, P2 to up to Pn. The set of all the active process in the system, and R is your R1, R2, Rn, the set of all the resource types in the system. A directed edge from process Pi to resource type Rj is denoted by Pi to Rj. It signifies that process Pi is an instance of resource type Rj and waits for that resource. Right? A directed edge from process Pi to resource type Rj, okay, is denoted by Pi to Rj. It signifies that process Pi is an instance of resource type Rj and waits for that resource. That means every resource having more than or one or a single instance, right? That means suppose the resource are having 4 instances. That means at a time 4th number of process it can be accessed all the 4 instances of the resource. If a resource has single instance, then a process one, that means at a time one process only access that instance. So that is the phenomena of resources. The directed is from resource type Rj to the process Pi, which signifies that an instance of resource type Rj has been allocated to process Pi. A directed S Pi to Rj is called as request S and Rj to Pi is called assigned H. So directed S Pi to Rj, that means process to resource is called request and request to process is called the assigned H. So there is some diagram in this process is a circular request type 4 instances, one request having 4 instances, P request instance R and P is holding the instance of the R. So this is all about for today's class. Next class we are going to discuss another topic or this same resource allocation graph. So thank you to all.